Okay, here we are on part 2, and we are looking at the binomial theorem. It teaches us how to take a binomial, two terms, and raise it to a power quickly. So we're going to use Pascal's triangle. It starts with 1, 1, 1, and then each row starts with a 1 and ends with a 1, and in between terms our numbers are made by adding the two above. Alright, hopefully you remember how to do that. Alright, we don't need much more than that to do this one. On a final, this number is not going to be too large because of time. So when it's raised to the 3, there's going to be 4 terms. And I'll put a little box that I'll get from Pascal's triangle, the coefficient. And we'll go over and grab those at the end. In the first term, the first number in the binomial is raised to the max. So x is raised to the third, and the second term does not appear at all. Then in the second term, the next term, this goes down by 1, and this second term appears, 3b. Then we take this term and it goes down by 1, and this goes, the exponent goes up. And lastly, the x disappears and 3b is raised to the max. Alright, now we need the coefficients, and we have 4 terms, so we're going to go to the row that has 4. So we're going to grab 1, 3, 3, and 1. And now it's just a matter of simplifying these. 1x cubed is just x cubed. 3 times 3 is 9, x squared b. And here we have 3 squared, which is a 9, times a 3, which is 27. And that leaves us xb squared. And lastly, 3 raised to the 3 is another 27, b cubed. So the final binomial is right there. All right. Back to probability and counting. How many 3-digit numbers, so right away I know I need 3 slots, can be formed that the leading digit cannot be 0. So of all the digits, the first one can't be 0, so that leaves us 9 possibilities. I'm sorry, if the leading digit cannot be 0 and repeats are not allowed. So I didn't read the whole thing. So we have 9 ways to fill in the first slot of this number, this 3-digit number. So we have chosen some number here. I don't know what it is. Suppose it's a 2. So we can't use 2, but we can use 0 now. So we still have 9 choices. Say we got a 4. So then there are 1, 2, 3, 4, 5, 6, 7, 8 choices. So 9 times 9 times 8 is 648. And I will check that answer. They said it was A, so 648 is how we counted those. Find the probability for the experiment of drawing 2 marbles without replacement from a bag containing 3 green, 6 yellow, and 2 red such that both are yellow. So we're going to do a probability, which is always a fraction. So on the bottom, we took a look at all the possibilities. Well, how many marbles are there in there? 3 plus 6 is 9, 11. So we're going to do 11 times 10. But up here, we have a requirement, and both are yellow without replacement. So how many ways can we draw a yellow on the first draw? Well, there's 6, but we're not throwing it back in the pot, so then it's 5. So we end up with 30 over 110. which reduces to 3/11. And that is selection D, and it is correct. How's that change if we do allow replacement? So I think that's the next one. All right. Oh, I didn't do that one. Okay, let's just talk about it. If we do allow replacement, then we put that yellow one back in, and this becomes a 6 instead of a 5. All right, the rest is the same. All right, on the next one, we are asked to find the vertex and the directrix of the parabola. So we recall that to do that, we have to get it in a form that looks like this. We have x squared equals 4py, or y squared equals 4px. And if Hector and Kyle are playing, which I think they will, then we're going to have x minus h equals 4p, y minus k. All right. Now this one, since it has an x squared term, is going to be one of these. So this, not the y squared one for this problem. So let's put this in this form. We do that by putting all the x terms on one side and pulling everything else over on the other side. When I do that, I get this. Now I'm going to complete the square here. So x squared minus 2x, what will I add to make it a perfect square? Half of this number is -1. -1 squared is 1. So I have to adjust for that over here by adding a 1. So what's the perfect square? X minus 1, quantity squared, equals 8y minus 33 plus 1 is minus 32. We'll be done when we factor the right, pulling out the 8, we get 8 times y minus 4. And now this is, so the question says what's the vertex? So the secrets of the vertex are facing us. This, the opposite of this is the x coordinate, the opposite of this is the y. And where do I get the directrix? So I know that the directrix is, if this is the vertex, then I know the directrix is, we're going to have, the secret to that is in here. And it comes from a quantity called p. So you can see 4p is taking the place of 8. So 4p equals 8. So p equals 2. So that tells me that the value for the directrix is going to be 2 away from the focus. And it's always p, I'm sorry, from the vertex. Vertex to the directrix is p, and vertex to the focus is p. All right, since this is a positive x squared, it's going to be opening to the right, so we are looking at this kind of, I'm sorry, this is a vertical, up and down. When it's an x squared, when you have this, it's a vertical. So x squared, it's positive, so, and that's the vertex, so it's going to be something like that. And we are looking for the directrix. So we're going to go, the directrix is always outside the parabola, the focus is inside, and it's going to be 2 away. So the focus would be here, and the directrix is a line here. So that is that y equals 2. Here it is, right here. That selection is D. All right, y equals 2, and I want to check that out if I got it right. Number 42, it is selection D. It is correct. All right. Now we switch to ellipse land, and we've practiced some of those with Alex, so hopefully these won't take us too long. But I'm going to go check my dinner, so I'll be back in a flash to finish 43, 44, 45, 46, 47, 48, 29 and 50, all the way to 50. So hopefully in one part. So I'll see you in a flash.